Hello, guys. Good evening, everyone. How are you guys? Hello, Divisha. So, guys, are we live now? Can you able to hear me? So, guys, are we live now? So, guys, let's confirm whether you can able to hear me, whether you can able to see me, so that we can start. Hello, Rishabh Singh. Hello, Sanidhya Sharma. Good evening, guys. So, guys, is my voice clear? Okay, right. Very good. Very good. Chalo, guys. Let's start then. So, welcome to 3000 practice problems. So, in this session, we'll discuss probability problems. So, let me introduce myself. Myself, Praneet Kalyanam. I'm maths educator at Unacademy. I have 10 years experience in teaching IIT-JEE. And I have worked in Narayana Educational Institute, China campus, Hyderabad. And then before that, I have worked in Akash, Bangalore. I'm from IIT Roorkee. Hello, Princey. Namaste. Right. So, guys, this is my profile in Unacademy. You can follow this profile so that you will get notification about my special classes and plus courses and plus batches. You will get everything related to the courses and batches. So, guys, you can take this subscription plans. If you want to join either Plus platform or Iconic platform, you can get the benefits out of this Plus and Iconic plans. You can just go through the advantage of this Plus and Iconic subscription plans, and you can enroll according to your wish. So you can take the subscription through your learning app only. In learning app, you can choose your goal IIT-JEE, and you can take the subscription, and you can choose your plan, and you can use a referral code Praneet10, and you get 10% discount. Very good. So these are the features we have, and these are the packages we have. So for 1 month, 3 months, 6 months, 12 months, and for 2 years, 6 months, and you can use this referral code Praneet10 to get 10% discount. And these are the packages for Iconic subscription, guys. If you can afford this Iconic subscription, you can go through this. Otherwise, you can choose Plus subscription also if you can't afford Iconic. Right, chalo guys, let's do this question. Everyone start doing this question. If two events A and B are such that P of A complement is given 0.3, P of B is given 0.4, and P of A intersection B complement also given 0.5. So from this, what is the probability of B by A union B complement? Conditional probability is asked. So from this, we can calculate probability of A. Why? Because probability of A is equals to 1 minus probability of A complement. So from this, we can calculate probability of A, which is 0.7. And then probability of B also given. And what is this from this? Probability of A intersection B complement he gave. Probability of A intersection B complement. So through Venn diagrams, easily we can analyze it, guys. Let's draw the Venn diagram so that we get the clarity. So let's take the sample space. So probability of sample space is always 1. So we can take it as probability of sample space is always 1. And there are two events here. One event is A and another event is B. So you can denote these two events with circles. Let's take these Two events are A and B. And the probability of these two events already he given. So probability of this is 0.4 and the probability of A is equals to 0.7. Probability of A and probability of B, we know it. And what is the probability of A intersection B complement, guys? Probability of A intersection B complement is this red color region. It should be in A but should not be in B. This region, guys. This region he is giving it as 0.5. This region he is giving it as 0.5. That means the remaining part is 0.2 only. In this case, remaining part out of 0.4, if this common part is taking 0.2, remaining part is 0.2. And here remaining part out of this A union B, other than A union B, in remaining part we get 0.1. Correct? Total is 0.7. So this red color shaded region is 0.5. So that's how we're getting Venn diagram easily, guys. So once we got the Venn diagram, so what he's asking, let's find out what he's asking. Probability of B by A union B complement. Let's calculate this formula. So this is nothing but probability of B intersection A union B complement by probability of A union B complement. Let's do this, guys. So let's take the numerator. Numerator is, it should be in B. B intersection means what? It should be in B. Same way, it should be in A union B complement. What is A union B complement? A union B complement is, it should be in A or it should not be in B. That means other than this 0.2, remaining every part. So otherwise you can write it this way. A union B complement, probability of A union B complement we can calculate, guys. Probability of A union B complement, I am shading it, guys, shading with white color, just check it. So it should be in A or it should not be in B. So that means this entire part we get it. This white color region, guys. This entire part we get it. Other than this 0.2, remaining everything we get it. So how much it is? It is 0.8. So, but what is the numerator? It should be in B and it should be in A union B complement. That is nothing but probability of A intersection B only, guys. By denominator we can calculate. Denominator is like probability of A union B complement. Already we calculated that. So here we are getting 0.8. So what is the numerator? We are getting it probability of A intersection B complement. A intersection B, we got 0.2 by 0.8. So if we do this, we are getting 1 by 4, which is equals to 0.25. So that's what the answer. So fourth option is the answer. Guys, is it clear? So fourth option is the answer. Everyone understood this? Okay, chalo, let's discuss the same question again. First, we calculated probability of A from the given quantity, probability of A complement. IIT Allahabad IT or DTU CS. I think IIT Allahabad IT will be better choice, I think. You can check with the previous campus placements and all. You can check those two ones. How was the previous 2 years campus placements and all. Priyansh. Right, so guys, let's see what we are doing here. Probability of A we calculated through probability of A complement, which is 0.7. And then probability of A intersection B complement. In the Venn diagram, we denoted red color, guys. Probability of A intersection B complement means it should be in A, but it should not be in B. So that is this red color part. So which is 0.5. If this is 0.5 and this whole thing is 0.7, this common part, that is A intersection B, is 0.2. And the remaining part in this total is 0.4, and other than this, remaining part is 0.2. And other than this A union B, neither A nor B. This part is neither A nor B. This is 0.1. And then This conditional probability we need to calculate. Conditional probability we can write it by using this formula. Probability of B intersection A union B complement by probability of A union B complement. Just now we calculated probability of A union B complement, guys. A union B complement is this white color shaded part. This white color shaded part, if you calculate, we're getting 0.8. So denominator is becoming 0.8, and numerator, if you calculate, numerator is intersection of B. B is this part, intersection of B and this white color part, intersection of B and this white color part, A union B complement, is probability of A intersection B only. It should be in B and it should be in this white color part. So B part is this and it should be in white color part. So that means only this A intersection B part only, this 0.2 part. So that's how this is becoming probability of A intersection B, and the numerator is becoming 0.2 by 0.8, 1 by 4, which is 0.25. So the answer is 0.25, fourth option. Clear? Right, perfect. Chalo, let's move to the next question, guys. See, these type of question we can easily analyze through Venn diagram, guys. If you try to analyze through Venn diagram, we get the answer very easily. Okay? Right. Next question. So guys, this is the next question we have. So guys, if you want to try this question, I'll give you 1 minute time. So everyone try this question. A bag contains 3 white, 2 black balls. There are 2 white and 2 black and 4 red color balls. If 4 balls are drawn at random with replacement, the probability that the sample contains just 1 white ball, the probability that the bag contains 3 white, right? So this is not 2 balls, this is 3 white. 3 white balls, 2 black balls, 4 red balls. 4 balls are drawn one by one. See, total how many balls are there? Total 9 balls are there. Total 9 balls are there. So when we want to draw 9 balls, one by one, how many ways we can draw? First ball, we can draw 9 ways. Second ball, we can draw 9 ways. Third ball, 9 ways. Fourth ball, 9 ways. So total 9 power 4 ways we can draw 4 balls. But out of this 4 balls, what he is saying is probability that sample contains just only 1 white ball it should contain. So out of this 4 balls, we should get exactly 1 white ball. So exactly 1 white ball means only 1 white ball we should get it, and the remaining all are non-white balls. So in that case, how many white color balls are there? Only 3 balls are there. From these 3, we need to select 1 ball, and the remaining 6 balls, we need to select 3 balls. So that means for that we'll have 6 into 6 into 6 possibilities we have. So now you can simplify this. Let's see if we simplify this, how much we get it, guys. So this is the probability of getting out of 4 balls drawn, there is exactly 1 white ball. Remaining balls, it can be any one out of this 2 blue color and 4 red color balls. So now let's simplify this. If we simplify this, how much we get it, guys? So 3, 3, 3, all this we can cancel it, and how much we get it? So 3 into 3 into 3 into 3. So under 2 9s we can cancel, and here 2 cube is there, so we can write it as 8 by 81. That's what we're getting it. Clear? Once again, guys, something went wrong. The probability of P getting a white ball in a single draw is 1 by 3. If X is the number of white balls drawn, then the probability is X minus with N is equals to 4. Therefore, the probability of getting exactly 1 white ball. So we need to get exactly 1 white ball. Out of 4 throws, we need to get exactly 1 white ball. So that means total we are taking 4 random experiments we are taking. Out of this, exactly 1 times we need to get the white ball. So the probability of winning white ball is 1 by 3. And the probability of not getting white ball is 2 by 3. So it is 2 by 3 whole cube. So now let's calculate this. 4 by 3 into, so this is 8 by 3 power 3 cube. So when we do this, 32 by 81 we're getting it. Yes, exactly. So 32 by 81 is correct answer. So guys, clear? Next one. For k is equals to 1, 2, 3, the box BK contains k red balls and k plus 1 white balls. So probability of B1, B2, B3 is given. So that means selecting probability of B1, selecting box B2, box B3 as given. A box is selected at random and the ball is drawn from it. If a red ball is drawn, then the probability that it has come from box B2. So guys, so we need to use probability of selecting box B1 he gave, probability of selecting box B2 he gave. So and then box B1 contains k red balls. Here if you take k is equals to 1, I am taking k is equals to 1. In that case 1 red and 2 white color balls we have. Next B2, for B2 k is going to be 2 guys. For k is going to be 2. How many red color balls and how many white color balls? 2 red color balls and 3 white color balls. Same way for B3. For B3 how many red color balls and how many white color balls? Easily we can calculate. This is white. How many white color balls? We can calculate just by substituting these values. I just substituted k is equals to 1. If you substitute k is equals to 1, k is equals to 2 and k is equals to 3 if you substitute, we get box B1 contains 1 red, 2 white. Box B2 contains 2 red, 3 white. Box B3, this is B3 guys. B3 contains 3 red and 4 white. Right. So now, what he is asking is, if a red ball is drawn, what is the probability that it has came from box B2? So we need to use Bayes' theorem guys. What is Bayes' theorem? According to Bayes' theorem, if I want to calculate probability of getting a red color ball from box B2, it is nothing but probability of B2 into probability of getting a red color ball out of B2 by, see this red color ball can be because of box B2 or because of box B1 or because of box B3. So it can be like this. Probability of box B1 into probability of red color when it is already known that it is from box B1. Same way, probability of B2 into probability of red color when it is known that it is from box B2. And the next, probability of B3 into probability of red color which is already known that it is from box B3. Clear? So now substitute all these values. Already we have calculated all these values. Probability of R by B2 we'll calculate now. Probability of R by B2. So probability of R by B2 is how much guys? What is the probability of selecting a red color from a box B2? Isn't it 2 by 5? Yes. Same way, what is probability of R by B1? When it is known that it is box B1, what is the probability of selecting a red color? Same way, what is the probability of R by B3? When it is already known that it is from box B3, how many red balls are there guys? 3 balls are there out of 7 balls. So these are the probabilities. Now let's substitute these probabilities here. If you substitute these probabilities here, probability of B2 already he gave 1 by 6 into probability of B2 is what? 1 by 3, right? 1 second guys. It is 1 by 3. Probability of B2 is 1 by 3 and probability of R by B2 we calculated, which is 2 by 5. This is 2 by 5 and divisible by, so tell me in denominator. probability of B1 is 1 by 2 into probability of R by B1, which is 1 by 3, plus probability of B2, already we know it, we calculated all this in the numerator, and denominator probability of B3, which is 1 by 6, into probability of R by B3, which is 3 by 7. So now we need to simplify this. Guys, we just need to simplify this. If we simplify this, let's see what we get. We can cancel 1 by 3 because 1 by 3 is there common in all the terms. 1 by 3, 1 by 3, 1 by 3, and here also 1 by 3 is there, and here it is 2 times. Now let's simplify this. If we simplify this, 2 by 5 by 1 by 2 plus 2 by 5 plus 3 by 14. That's what we're getting it. So we can simplify this. Let's simplify this here. So we can multiply both numerator and denominator with the 110, guys. If you multiply both numerator and denominator with 110, so how much we get it, guys? Why? Because LCM of denominator is 110, guys. So we can multiply this quantity with 110. If you multiply with this 110, we get the answer, which should be 14 by 13. That's clear? Probability of B2 into 1 by 3 into 2 by 5, 1 by 2 into 1 by 3, 1 by 3 into 2 by 5, 1 by 6 into 3 by 7. Correct. This we need to simplify this. This if you simplify it, 14 by 39, we're getting it. Correct. Guys, understood? Anyone has any doubts? How we calculate it? We are using this Bayes theorem. See, red color ball can be obtained because of box 1, box 2, box 3. But what is the probability that red color, already we know that red color ball is occurred. What is the probability that this red color box is occurred, red color ball is occurred because of this box B2? Clear? Right, perfect guys. Chalo, let's move to the next question. Hello Mayank, how are you? Right, chalo, next question. 6 coins are tossed together 64 times. If throwing a head is considered as success, then the expected frequency of at least 3 success. That means at least 3 success we should get, means out of 6 coins, we need to get at least 3 heads we should get it. See, when 6 coins are tossed, getting at least 3 heads means what? 3 heads, 3 tails, or 4 heads, 2 tails, or 5 heads, 1 tail, or all 6 heads. These are the possibilities we have. When 6 coins are tossed together, 64 times, if throwing a head is considered to be a success, then the expected frequency he is asking. So first we need to calculate what is the probability that what is it, Mayank? Prilipko. What is it? Right. So first we need to calculate when 6 coins are tossed, what is the probability that we get 3 heads, 4 heads, 5 heads and 6 heads. Right. So when we calculate the probability of getting at least 3 heads, let's see what we get. Probability of getting at least 3 heads. Otherwise you can take it something like this. Probability of getting at least 3 heads, that means greater than or equals to 3, you can take it. That is equals to probability of h is equals to 3 plus probability of h is equals to 4 plus probability of h is equals to 5 plus probability of h is equals to 6. So let's calculate all this. Okay, yeah. Bomb sound you are able to hear, Mayank? Okay. So few guys are here. Crackers are they're firing the crackers. Maybe some festival is there, right, today? Because of that, so they are firing crackers. So that's why I'm using headphones today. But still, is it creating lot of disturbance, guys? Is it creating lot of disturbance, or is it fine? Right. So now let's calculate this, guys. So if we calculate this value out of 6 coins, we need to get exactly 3 heads, means isn't it 6c3 into 1 by 2 whole cube into 1 by 2 whole cube, plus out of 6 coins exactly 4 heads we should get, it means 6c4 Guru Nanak Jayanti, correct. Whatever, I don't know what is that festival. Because of that festival they are firing the crackers, I don't know why. Right, so this is 1 by 2 whole power 4 into 1 by 2 whole square. Same way, 6c5 into 1 by 2 whole power 5 into 1 by 2 whole power 1 plus 6c6 into 1 by 2 whole power 6 into 1 by 2 whole power 0. So now if you add all this, how much you get it, guys? Let's check it, how much you get it. When you add all this, see, denominator is fixed, denominator is like 2 power 6. And a numerator we need to calculate. What is 6c6, guys? 6c3 is equals to 6 into 5 into 4 by 6, which is 20. So here 20 will get it. And 6c4 is how much, guys? 6c4 and 6c2 is same. 6 into 5 by 2, which is 15. 15. And 6c5, 6. 6c6, 1. So now if you calculate all this, how much we get it? 30 plus 15, 20 plus 15, 35. 35 plus 7, 42. 42 by 2 power 6 we are getting it. This is the probability of getting at least 3 success. But what he is asking, expected number he is asking. What is expected number, guys? Expected number is equals to total number of times we are performing these operations. That means tossing 6 coins. This is a 6 coins is equals to expected value, expected number of success. E of S, you can take it as E of S. E of S is equals to number of times we are performing this operation into probability of A, probability of getting success, or you can take it something like this. Probability of getting success. Expected number of success is equals to number of times we are conducting this operation into probability of getting success. So when we do this, so tell me, guys, how much we get it? 64 into probability of getting success, already we just calculated, 42 by 2 power 6. 2 power 6 is 64 only, these two get cancelled, and how much we get it? 42 we get it. So that means out of 64 times, on an average, 42 times we get success. At least 3 success, we get it 42 times. Okay? Yes, that's what we get it. So guys, clear? Everyone understood this? Hello Rishabh, Sher Singh. Right, perfect. So can we move to the next one? Chalo guys, let's move to the next one. Yeah, this is the next question. Probability of A is given and probability of B is given. Probability of A intersection B also given. Then what is the probability of A complement by B complement into probability of B complement by A complement? Okay, let's do this. This we can simplify it first. If you simplify this first, probability of A complement by B complement is probability of A complement intersection B complement by probability of A complement into probability of B complement by A complement is probability of B complement intersection A complement by probability of A complement. Oh, sorry, this is reverse, guys. So here we did mistake here. So this is going to be not A complement. This is going to be probability of B complement. That's what we're getting. Correct. Right. So now we can solve this probability of A complement and B complement. All this we can calculate from the given information. From the given information, we can say that probability of A complement is equals to 1 minus probability of A, which is 3 by 5. Same way, probability of B complement we can calculate. Probability of B complement is 1 minus probability of B, which is 7 by 10. And then probability of A union B also we can calculate. A intersection B he gave. So from this we can calculate probability of A union B is equals to probability of A plus probability of B minus probability of A intersection B. We have this formula, addition theorem. So in this, if you substitute, what we get? Probability of A union B, probability of A, yes, he gave 2 by 5. Probability of B, he gave. Probability of A intersection B, he gave. So now let's take LCM. LCM is 10. So tell me how much we get it, guys. Here 4 plus 3 minus 2. So total how much we're getting it? 5 by 10, which is equals to 1 by 2. Okay, probability of A union B we calculated. And what is the probability of A complement intersection B complement? Let's calculate this. Probability of A complement intersection B complement is probability of A union B whole complement only. Correct. Probability of A union B. A union B whole complement is A complement intersection B complement. This we can calculate this way. 1 minus probability of A union B. A union B just now we calculated, which is 1 by 2. So this is 1 minus 1 by 2, which is equals to 1 by 2 we're getting it. So now all these values you substitute here. If you substitute all these values, numerator is 1 by 2. By denominator is probability of B complement, which is 7 by 10. And numerator again 1 by 2, and probability of A complement we calculated 3 by 5. Now let's simplify all this. JEE कब होगा? JEE must be in February, guys. By end of the February it should be. End of the February or February or March. Okay. Right. So guys, so tell me how much you're getting it when you do this. So this we can write it as 5 by 7. And this we get it like 5 by 6. Right. So tell me how much we get it. 25 by 42 we're getting, guys. 22 by 42 should be the answer. Third option is the answer. Guys, everyone understood this? Yeah, March में भी हो सकता है. Mid of the February to end of the March. It can be anywhere in between mid of the March to end of the mid of the Feb to end of the March. We can't tell exactly when it will happen until official notifications comes. So 25 by 42 we're getting, guys. Is it clear? Everyone understood how we calculated? First we calculated probability of A complement and probability of B complement. And then probability of A union B we calculated. From this probability of A complement intersection B complement we calculated. And then if you substitute all these values here, we get 25 by 42 we get. Clear? Right. Perfect, guys. Chalo, let's move to the next one. Yeah, this is the next question we have. Binomial variate, X has a mean. See, for guys, for binomial variate, mean formula is NP, guys. NP is 6 and variance is NPQ. Mean formula is NP and variance is equals to NPQ. According to this, NPQ is given as 2. So if you divide these two equations, what we get it is Q value we can able to calculate. Why? Because NPQ by NP if we calculate, we get Q only. And this we get it like 2 by 6, which is 1 by 3. So Q value we calculated. Yes, Mohit, I am from IIT Roorkee. So same way, can we calculate P, guys? Why? Because see, P plus Q is equals to 1, guys. Once you get Q value, can I calculate P value? 2 by 3 only, right? So once we calculate P value and Q value, you can substitute these values here. So NP is equals to 6. Once we got NP is equals to 6 and P value is 2 by 3, let's substitute here. NP is equals to 6. So N into 2 by 3 is equals to 6. From this N value, how much we getting, guys? So 9 we are getting it. N value is 9. So we calculated N value. IIT professors will teach in English only, guys. So better you start learning English. Okay. So why? Because if you don't know English, you feel definitely difficult after joining IIT or NIT, guys. Why? Because most of the faculty, not only most of the faculty, every faculty will teach in English only. At that time you feel difficult. So better learn basics of English. Okay. Why? Because I'm just talking simple English only. So if you can able to understand, that's fine. So if you just, yes, exactly. I am from Hyderabad, Mohit. Right. So guys, we calculated N is equals to 9. Once we got N is equals to 9, let's see what he is asking. Probability that X should lie between 5 to 7. Let's calculate this. Mohit, don't spam. Probability of 5 less than or equals to X less than or equals to 7. This is what we need to calculate. So let's see. So this is nothing but probability of X is equals to 5 plus probability of X equals to 6 plus probability of X equals to 7. Right. So tell me, what is this? Let's calculate this value, guys. So probability of X equals to 7 is 9C5. Why? Because NCR, but here N is 9, we calculated already. 9C5 into probability of success. Probability of success is 2 by 3. 2 by 3 whole power 5 into 1 by 3 whole power 4 plus 9C6 into 2 by 3 whole power 6 into 1 by 3 whole cube plus 9C7 into 2 by 3 whole power 7 plus 1 by 3 whole square. This is what we should calculate. So if you calculate this, you get the answer, guys. Clear? So if you calculate all this, that's what? If you calculate all this, so we get the answer. What is it, guys? We're getting third option as an answer. Guys, is it clear? So third option is the answer. Near New Paradise. Okay. Okay, good, Mohit. So guys, any doubts in this? Anyone has any doubts? Perfect. Chalo, let's move to the next question. Next, 7th question, guys. E complements denotes the complement of event E. Let EFG pairwise independent. Pairwise independent means what? E and Z are independent, F and Z are independent, even E and Z are also independent. Independent means what? Suppose if E and F are independent, probability of E intersection F is equals to probability of E into probability of F. Same way with remaining also. That is probability of E intersection Z is equals to probability of E into probability of Z, like this. And probability of E intersection F intersection Z is given as 0. Probability of F intersection Z is equals to probability of F into probability of Z. And probability of E intersection F intersection Z is given as 0. And now what he is asking, we need to calculate probability of E complement intersection F complement by Z. So conditional probability we need to calculate. Let's calculate this value, guys. Probability of E complement intersection F complement by Z is probability of E complement intersection F complement intersection Z by probability of Z. That's what we need to calculate. So let's calculate this. So if you draw the Venn diagram, you can easily analyze this, guys. Let's draw the Venn diagram. So if you draw the Venn diagram, this Venn diagram consists of three events. One is E, another one is F, another one is G. And now what he is asking, probability of E complement. That means it should not be in E, it should not be in F, but it should be in Z. So that means what this shaded part he is asking is, this green color shaded part is numerator. This green color shaded part is numerator. Anyway, this part is 0. Why? Because he is saying the common part is 0. So can we say that this numerator, can I write it as a probability of Z minus probability of Z intersection F minus probability of E intersection Z? Can I say it like this? By denominator is probability of Z. Now let's simplify this, guys. So if we simplify this, let's see what we get it. This we can write it as probability of Z minus probability of Z intersection F. Already we have this formula, guys. You can see this formula. So can I replace this part with the probability of F into probability of Z? Same way. Second part, probability of E intersection Z also. Probability of E into probability of Z by probability of Z. Now can we cancel probability of Z from this? Yes, we can cancel probability of Z. All this we can cancel probability of Z. Finally, 1 minus probability of F minus probability of E. Clear? So, but see here, 1 minus probability of E is how much, guys? 1 minus probability of E is probability of E complement only. Correct? This we can write it as probability of E complement minus probability of F. So, this is going to be the answer. Where this answer is there? Third option. Yes, correct. Aniket, you're right. So, third option is the answer, guys. Probability of E complement minus probability of F. So, guys, is it clear? Everyone understood this? Can we move to the next one? Next one. Yeah, this is the next question we have. Suppose X is a random variable which takes values 0, 1, 2, 3 for the value of R, and P is lying between 0 to 1 and Q is 1 minus P, that means P plus Q is equals to 1. Then which one of the following is correct? So guys, we know that sum of the probabilities is equals to 1. So let's calculate sum of the probabilities. If we calculate sum of the probabilities here, that is sigma R is equals to 0 to infinite or whatever it is, into P into Q power R is equals to P into, you can substitute R is equals to 0 here, substitute R is equals to 0, 1, 2, 3, all these values, 1 plus Q power 0 plus Q power 1 plus Q square plus so on up to infinite. So this is like infinite ZP. For infinite ZP, 1 minus Q we're getting it, so P by P we're getting 1. So nothing we are getting from this. From this we're getting sum of the probabilities we try to calculate and we're getting 1 only. So nothing we are getting here. Okay, so now what he's asking here. So probability of X greater than or equals to, he's asking. Let's verify the first option, guys. If you verify the first option, what we get it. So there is no use of doing this statement. So I am erasing this statement. So why? Because from this we didn't get anything. Right. So now let's verify the first option. When we try to verify the first option, whether it is correct or not, we'll get to know. Let's take the first option. So first option is probability of x greater than or equals to a is equals to probability of x equals to a plus probability of x equals to a plus 1 plus so on up to infinite. So when we calculate all this, what we get it is p into q power a plus p into q power a plus 1 plus p into q power a plus 2 plus so on up to infinite times. So now what we can do, we can take p into q power a and the remaining part if you take common, so we get it like this 1 plus q square plus so on up to infinite times. So this is in infinite GP guys, this we can simplify it. This is like 1 by 1 minus q, but 1 minus q is p only. So p into q power a by 1 minus q is p. So we can cancel this p and p guys. P and P cancel and finally we're getting q power a. So exactly whatever he is saying in the first option, we got it correct. Right. So first option is the answer guys. Is it clear? Everyone understood how we got this? Is it clear? So but actually in fourth option, all of the above is there. So once we got the first option, we can't conclude that first option is the answer. Why? Because of this all of the above, maybe remaining options also correct. If the remaining options, that means option B and option C is correct, then we can conclude that all of the above is correct. So at least one out of this B and C is wrong, we can conclude that option A is correct. So now what we need to do is we need to check option B is correct or not. Let's check it option B is correct or not guys. Right, clear? Aniket, here not raining, but actually because of this some festival here, they're firing the crackers. Is it a disturbance guys? Is it disturbing you? Right. So guys, this is the fourth class in probability. Already we have done previous year questions in probability. 2020, 2019, all these questions already we finished. Okay, in the previous sessions. So now in this class, we are doing other than previous year questions, we are doing some other questions. Okay, chalo, let's verify the second option guys. Let me verify the second option. So second option, what he is saying is probability of x greater than or equals to a plus b by x greater than or equals to a. Okay, that's what he is giving it. Is equals to probability of x greater than or equals to b. That's what he gave. Okay, right. Let's do this. Probability of x greater than or equals to a plus b by x greater than or equals to a. Is equals to, let's see how much we get it guys. So this is a conditional probability. We can say it like this. Probability of x greater than or equals to a plus b intersection with probability of intersection with x greater than or equals to a by probability of x greater than or equals to a. Already probability of x greater than or equals to a we calculated in the first option. First option we already calculated this. So we can use that result already. Okay. And then what he is saying, numerator, let's see what he is saying. Numerator, probability of x should be greater than or equals to a plus b and x should be greater than a. What is the common part out of these two? It should be greater than a plus b and greater than a. So compulsory probability of a and b should be greater than a plus b. So in that case, probability of x greater than or equals to a plus b, when we do this, what we get it is, this is nothing but probability of x greater than or equals to a plus b only we get it. By probability of x greater than or equals to a we get it. So when we substitute in the first result, what we get it, this is coming like q power a plus b by q power a we get it. So this is nothing but q power b only, but q power b, can I write it as a probability of x greater than or equals to b, correct? So whatever second option he is saying is correct. So same way, obviously third option and fourth option also correct. So finally the answer is going to be fourth option because all options are satisfying it. So we can say that fourth option is correct answer. Guys, is it clear? Everyone understood this? So x greater than or equals to a plus b, intersection x greater than or equals to a is nothing but x greater than or equals to a plus b. So and x greater than or equals to a plus b means in the first option in place of a we have a plus b, that's it. That's why in place of a I just substituted a plus b. Q of a, q power a plus b by q power a is q power b. But q power b is nothing but probability of x greater than or equals to b only. Correct? So we can say that second option is satisfying, first option is satisfying, so obviously the answer should be fourth option. Same way you can verify the third option also, guys. You can verify the third option also. Okay, right, clear? Perfect. Right. So guys, let's do the next question. Yeah, this is the next question we have. N letters to each of which correspond on addressed envelopes are placed. Okay, right. So next chapter, guys, we started algebra already. In algebra, we completed binomial theorem, complex numbers, and permutations and combinations, probability we completed. How many questions will you cover from probability? From probability, we already completed more than 50 questions already. HM math. So we'll go to the next topic in the day after tomorrow's class. Why? Because we'll have every Monday, Wednesday, Friday night 9:30 p.m. we'll have class, guys. Okay. So already we completed 4 classes on probability. So we'll go to the next topic. Okay, so next topic, we can take matrices and determinants. Okay, right. So guys, let's do this question. Permutations and combinations is over, guys. Before probability, already permutations and combinations we finished. So if you want, you can watch the recorded sessions. So n letters of each of which correspond one address envelope are placed in the envelopes at random, then the probability that n letters placed in the right envelope. See how many ways we can place n envelopes in right envelopes. N letters we need to put it in n letters in n envelopes right order can be put it in only one way. So there is only one way to put n letters in n envelopes in a right way. Okay, so this, the probability of this by total number of ways, probability that n letters we can place it in n right envelopes. But actually, how many ways we can rearrange this n letters in n right envelopes, guys? Why? Because see, n factorial ways we can arrange it. But out of this n factorial ways, how many ways we can rearrange in such a way that no letter should go to the correct envelope? That's what. Then the probability that n letter is placed in the right envelope will be. So this question looks like there is a mistake in this, guys. Why? Because these options look like dearrangement. Number of dearrangement. These options look like dearrangement, but here he is not at all talking about dearrangement. And the probability that n letters is placed in right envelopes. He's asking about right envelopes. Actually, if you ask about wrong envelopes, then one of these options will be the correct. But he is talking about right envelopes. If he is talking about wrong envelopes, then option 3 is going to be the correct. Okay, right, clear? So that's what he is talking about. This third option as answer means instead of taking right here, we should take wrong, guys. then in that case we'll get the correct answer. Guys, is it clear? So there is a mistake in this question. Just leave this question and move to the next one, guys. Yeah. Tell me. So you want theory, Aniket? Okay, right. Definitely. Definitely. But not on this series. So this series is 3000 practice problems. So in this we'll discuss practice problems. Okay. Right. Chalo, guys. Let's discuss this question. A bag contains n balls. It is given that probability that among these n balls, exactly r balls are white is proportional to r square. Okay, so that means the probability that among n balls, exactly r balls are white is proportional to r square. A ball is drawn at random and it is found to be white, then the probability that all the balls are all in bag are white. So that means out of n balls, all balls are white color balls, right? So here we need to use Bayes theorem again. So we know that it is a white color ball and he is saying that all balls are white color balls only. That means out of n balls, all balls are white color balls only. So what is it, guys? This is probability of only one white color ball into probability of getting a white color ball when it is already known that it is only one white color ball. But what he is saying is probability that all the balls are white. All the balls are white means here instead of taking 1 here, we should take n, guys. Instead of taking 1 here, we should take n. Let's take here n. So that means probability of selecting n balls by probability of having only one white color ball, and what is the probability that when it is there only one white color ball, what is the probability that white color ball when it is already known that it is only one white color ball, plus probability of 2 into probability of w by 2. So plus so on up to probability of n into probability of w by n. Let's calculate this. So let's see how much we get it. Probability of n is how much, guys? We know that probability of n is proportional to n square. So maybe you can take it something like n square k into probability of w by n. See, when there are all balls are white color ball only, then probability of white by w by n is 1. And what is this? Probability of one ball is probability of getting only one ball. Isn't it 1 square k? 1 square k into. So tell me, what is it? Probability of getting only one ball, and if there is only one ball, how many, what is the probability of getting white color ball? See, total how many balls are there? N balls are there. Out of n balls, only one ball is white. Remaining all balls are remaining color. So it will be like this. Next, 2 square k into 2 by n plus 3 square k into 3 by n, like this, guys. Plus so on up to n square into k by n. That's what we're getting it. N by n. So now let's simplify this. K value is getting cancelled because k is just a constant. So k we can cancel throughout all the terms. We can cancel k, and the remaining part will simplify it. Remaining part. So if you multiply both numerator and denominator, numerator we are getting like n cube, and the denominator we are getting like 1 square plus 2 square plus 3 square plus so on up to n square. That's what we're getting it. Correct, na? N cube or n square? N cube, right? It's n cube, na? Right? It's n cube, 2 cube, 3 cube, so on up to n cube. So cube we get it. Correct, Aniket, you're right. So now we can simplify it. Numerator is n cube and the denominator is like sigma n cube, guys. So sigma n cube formula is what? Sigma n cube formula is n square into n plus 1 whole square by 4. So substitute this value here, n square into n plus 1 whole square by 4. So tell me how much we get it. Are we getting 4n by n plus 1 whole square? Are we getting 4n by n plus 1 whole square? Yes, we're getting 4n by n plus 1 whole square. Guys, is it clear? Right, that's what we're getting, guys. So second option is the answer. Guys, is it clear? Everyone understood this? Any doubts, guys? So that's it, guys. That's it for today. Yeah, second option is the answer. So next class is going to be on Wednesday, guys. As today we have Monday. Next class is Wednesday and the next one is Friday. Every Monday, Wednesday, Friday, 9:30 p.m. We'll have a 3000 practice problem session. So come and join this session, next session. Next session will be matrices and determinants, guys. Okay. So chalo, guys. See you then. Everyone take care. See you in the next class. Bye bye, guys. Good night. Right. Definitely, Aniket. I'll send the notes, guys. You can find these notes after the class. You can find the notes in description links. You can find it. You can download it and you can keep it. And you can try the remaining questions. 2 more questions are there. If you want, you can try these questions. One is 11th and next one 12th. You can try these 2 questions. Okay. Right. Chalo, guys. Bye bye. Take care.